All right, yes, it's another sine law warm-up. Just for the 3M people won't know what I'm talking about here. The 3U people, I'm going to keep asking you several times a day to draw your two special triangles. But burned in your skulls. 3M people can get right to finding some sides and angles using the sine law. For 3U people, for the first one, I want you to find the exact side length. Feels like a Sunday. Surely you all are too old for trick-or-treating. Yeah. I didn't shame any teenagers that came to my house. I gave them the candy. We had 100 at my house. Ooh. All right, I'm gonna play catch up. So the special triangles, the 3U people, should be quick and automatic. So your 45, 45, 90 triangle, 45 degrees, 45 degrees. Side lengths of 1, legs of 1, hypotenuse is root 2. And if you forget the root 2, you could just use Pythagorean theorem to figure it out. So just make legs of 1, Pythagorean theorem goes to the root 2. So again, you got the 3U people, you need to know your special triangles. And then if you make half of an of an equilateral triangle, it's 30 degrees. No, wait, that would be 60. It'd be 60 degrees, 30 degrees. The hypotenuse is 2. The bottom side is half of that, 1. And then if you use Pythagorean theorem, you get the vertical side is root 3. You can go back and watch that lesson on how we made those. But the 3 people just got to know them. And then you guys are going to use the 3U people. I'd like you to use those exact values for sine in part A. I've given you guys special angles, 60 and 45, so you guys should be able to find side B exactly. 3M people, decimal's fine. And then in B, we're all just finding the angle. It'll be some decimal value. I'll leave those up there for a second. All right. I'm going to play some catch up here. Eight over sine 60. So our and I'm still recording it. So our 3M people will just slam that into a calculator and get an approximate value, which is fine. I'm going to actually do the exact version with the 3U people, and we can check afterwards. Just as an aside, because 3 people have the luxury. Like if you just want to go down and take the 3M course, you have that option like all the time. You can just go and there's no rearranging the schedule. You come to the same class and you'll do the 3M stuff. That's always been an option. It still is. But let's continue here. So you guys, of course, have your special angles, special triangles down. The sine of 45 degrees, opposite over hypotenuse, is 1 over root 2. And the sine of 60 is, what is that? Root 3 over 2, right? I mean, that's it. but I'm gonna clean that up a little bit. So uh, let's do let's go left to right, be a bit naughty here. So on the top, that's like 8/√2, and on the bottom, we're dividing by √3/2, and you guys all know how to divide fractions. That's like multiplying by 2/√3. And so exactly, you get 8 times 2 is 16. And on the bottom, √2 times √3 is √6. Exactly. Now let's compare for the 3M people. You guys just would have done 8 sine 45 over sine 60. And we should get the same thing. 16 divided by the root of 6 is about 6.53. So 3M people, anybody, you guys get about 6.53 when you did it? Yeah, see some nods. Okay. So I wanted to do that question because, just I tried to mix in that 3U bonus content we've been doing. I wanted to mix it in somehow. So I thought that'd be a good exercise. And of course, it's centimeters, meters, it's centimeters here. Okay. You guys can, I'll wait a second for you guys to go on to B. B, 70, what is it, 37 degrees there. It's not a special angle. We're going to be getting the approximate decimal value for that angle. I was pleased to see how the sine law is going with the 3M students, who that's new for most of you guys, not everybody, but. All right, for the sine law for angles, this is not, you don't have to do this, but I like doing it. I'll put my angle in the top left, just making the proportion easier to solve. And then just like before, 24 goes up top. So at this point, since the people that took grade 10 academic saw the sine law last year, and we've spent 2 days kind of reviewing it, for the 3M people, you've had 2 days to learn it and practice it. Hopefully, this is just kind of automatic at this point. 24 sine 37 divided by 20. 0.7222 is if you round correctly. But if you use 0.7221, you'll get the same answer. I know that some of you guys do these two steps kind of all at once, which is fine. Shift sign, 46 degrees, 46.2 degrees. And for the 3U people, clearly this is an acute angle. The context of the question would imply, okay, yeah, 46.2. We don't need to use yesterday's stuff here. It's clearly an acute angle. All right, on the back, what do I even have on the back? I made this up like 2 hours ago. I already forget. Yes, I gave you guys a double triangle problem where you have to mix and match some tools we've been reviewing / learning. And while you guys give this one a go, I'll pass around the next thing we're all going to do together. Common theme when you're doing a double triangle problem and like the side you want doesn't have enough information in that triangle is usually like find that shared side is always usually a good bet. Note that ACD is a right angle triangle if you want to use your SOHCAHTOA stuff when you get there. I'll pause briefly. All right, here I come. So that angle at C, dialing in that left-hand triangle, and there's so much space here on our page, it could be worth just redrawing. I'll do that too. So A, B, C. So this angle's 87 degrees. This one's 65 degrees. This one's 13 meters. So per my hint, finding that shared side is never a bad idea. I'll just label it B. And yeah, it's just applying the sine law. I know you guys have done a lot of this already, but maybe a bit of overkill. A bit of repetition is not a bad thing. Did I press play? Yes, I did. B over sine 65 equals 13 over sine 87. And yeah, I'll continue to show the minimum amount of work finding sides with the sine law. Thirteen equals divided by sine 87 equals to one decimal place 11.8. It's 11.8. 11.79817021, blah blah blah. And that's meters. And then can we use the SOHCAHTOA or the sine law for this one? Let me just redraw this one out too. So that's a right angle. This is 11.8 meters. This angle is 74 degrees. And we're finding x. Yeah, did anyone use the sine law for the second part? Yeah, if you like the sine law, then just use the sine law. Hopefully you found this third angle though, because that makes a side angle pair with 11.8. Of course, because if you use the 74-degree angle, 11.8 is the adjacent side. I'm just going to use cosine, and we should get the same answer. Cosine is adjacent over hypotenuse, and then it's on the bottom. So 11.8 divided by the cosine 74 should get the same thing. And if you use the sine law, that's fantastic. That seems long, but actually I think it's okay based on the diagram. 42.8? No, not sine law people, not 42.8? 41.1? Did you guys use 11.8? Oh yeah. Why? Yeah. Good catch, guys. Okay. Yeah. So this is a case where, yeah, it's definitely tan. Thank you. Where the differences we were getting were just too much. It's the tan of, and that should be x over 11.8. Okay. So I think we all just need the weekend, don't we? All right, let's try this again. Tan of 74 is x over 11.8. So that means we're using multiply 11.8 times the tan of 74. This will work, surely. Times tan of 74. Okay, 41.1 now? Okay, good. But I like that some of you guys use the sine law there. As we've been talking about, there's often more than one tool to do the job. And if you're really comfortable using the sine law, maybe I should have, use the sine law. If you're comfortable using SOHCAHTOA, do that. All right. On anything you guys want to chat about regarding the warm-up? 3U people, maybe this weekend, a couple times, just draw your special triangles out just so you have them down and you can reproduce them on a test. Today we're learning about the cosine law. So for the 2D people, you are reviewing the cosine law, but this is new for the 3M people. But why do we need this? We already have the sine law for our non-right angle triangles. One of you guys, share or refresh our memories? What was the condition we need to use the sine law? We just can't use it all the time. There was a condition we need. Graham, you remember? A pair, you need a side and its opposite angle. We called it a side angle pair. So have a look at those three triangles. Which of those can be solved using the sine law? I'll let you guys have a quick think on that. So you're just looking to see, do we have a side angle pair or not? It's only C that you can use the side that you have a side angle pair. that you can use the sine law. The other two triangles are cases we haven't yet done yet as a group. So can you guys just jot this down? I call these kinds of triangles, they're like a side angle side triangle where you have two sides and the angle in between. So you kind of have an angle sandwich. And then in B, you have a triangle that's all sides, SSS. And in triangles like these, you don't have a side angle pair, so you can't use a sine law. So we need something different. Sine law isn't enough to solve acute triangles. So let's just jot that down. So I'm just going to write SAS. I talked about what that means. It's a side angle side triangle, or SSS triangle. Does not have a what I call a side angle pair. You cannot use the sine law. And if we can't use the sine law and they're not right angle triangles, then at least for the 3M people, we don't have a tool for the job to solve these kinds of triangles. But we're going to complete the trigonometry puzzle today and learn something called the cosine law. For the people that took 2D last year, you'll be reviewing the cosine law. Now, in years past, I've done kind of a big numerical investigation, but I think for the sake of time today, I've just got an applet pulled up that's hopefully going to convince you that the cosine law holds when I show it to you. So let me get that pulled up here. All right. Get out of here. There we go. All right. So what I have in this applet here is I just have, oh, that's really dark. If you're purple colorblind, sorry, but otherwise I think everybody should be able to make that out. But this is a right angle triangle. The angle ACB here, ACB is 90 degrees. The side lengths here are 8, 6, and 10. And hopefully you guys are convinced, when you square A, you square B, you get 64 and 36. That adds to 100 centimeters squared. The hypotenuse is 10. You square 100, you get 100 centimeters squared. That's the Pythagorean theorem, right? C squared equals A squared plus B squared. Now, the question for today is, what happens when the angle is like not 90, but really, really, really close to 90? Kennedy, Richard, you with me? This is new stuff for you guys. What happens when the angle is close to 90, but not quite 90? So I'm going to take my point A and just drag it a little bit, just a bit, just a bit. See, it's not a perfect right angle triangle anymore. The angle is 0.06 degrees off of being a right triangle. And now the A squared plus B squared is 100. C squared is close to, but not quite equal to 10. It's very close, but not quite equal, or to 100. And then if I go even farther, and I make this a triangle that's not even close to a right angle triangle, you guys can see it's not that just the Pythagorean theorem isn't close anymore. Go away, Weebly. It's not even close at all, right? So how can we account for that difference? So I'm more moving towards using the cosine law, just actually showing you guys what it is, and worrying about the proof for like the scope of a different course. But I'm going to shift my triangle down here. Maybe make it a little tinier. And come down, come down. There we go. All right. I just have this random triangle here now, and you can see A squared and B squared and C squared are way different. But when you take the difference of A squared plus B squared and C squared, in this triangle they're off by 34.59. There is a calculation, and we can it's not hard to prove this, but I think it's kind of beyond the scope of our courses. If you take 2 times those two sides A and B times the cosine of angle C, note that you get that difference. It kind of makes up the difference. And as I change this triangle around dynamically and just kind of randomize it, you guys will note that A squared plus B squared does not equal C squared, but if you take the difference, it's always matched by 2AB cos C. So just have a look as I change this triangle around. You guys can see it's always the same difference, right? It's always the same. 2AB cos C is like the magic difference maker. So any triangle you can see, you can just mix it up. It's still the same difference. So this is the cosine law that basically says, okay, Pythagorean theorem doesn't hold for all triangles, but if you add in this extra term, it does. So what does that look like? Let's write that out. The cosine law says this. So for any triangle, ABC, for any triangle, ABC, the following is true. C squared equals A squared plus B squared. That's only true for right angle triangles. But if we subtract twice the product of those two sides A and B times, I'm going to use a dot for cosine here, or for multiplication here, times the cosine of angle C. This is true for any triangle, not just right angle triangles. And the 3M people can do this too. The 3U people learned this a few days ago. When you do have a right angle triangle, can you guys put in, what's the cosine of 90? What does your calculator give you when you do cosine 90? Cosine 90 is 0. So if you have a right angle triangle, all that's 0, it's Pythagorean theorem. But for non-right triangles, adding in this little bit here makes it hold. What's actually cool is that this relationship is true no matter how you rearrange the sides. So I have some space here. For this triangle ABC, not only is C squared equal to A squared plus B squared minus 2AB cos C, we can write a similar cosine law for side B, where you have the other two sides squared and added together. A squared and C squared minus 2, and then AC times the cosine, since on the left-hand side we have side B, times the cosine of angle B. And we could write another version for side A. A squared equals B squared plus C squared minus 2, this time, times BC times cos A. So pretty neat. It's the cosine law. Hopefully you're kind of convinced. But yeah, just based on past experience, not a lot of value is added, taking 10 minutes to do a numerical investigation. So I'm just giving it a try today, just kind of giving you guys the cosine law and getting right to it. I have a couple of notes. The first one I kind of showed you guys. When angle C is 90 degrees, the cosine law turns into the Pythagorean theorem. And that's because the cosine of 90 is equal to 0. And you guys verified that on your calculators. And then I do want to add a second note to say this. The cosine law can be used to find sides and angles. But today, we're just going to focus in on doing sides. Sine law, I felt we could get away with doing sides and angles in one day. Cosine law, especially if it's new, I feel just requires a couple of days. So if if we take our time, hopefully the 3 people are okay with that. All right, and I think we're gonna do 3 examples where we just give the cosine law a spin. Armed with your scientific calculator, it's actually pretty easy to use. You just gotta be careful setting it up. So let's get a bit of practice. All right. Let me know, you want me to leave that up for a second? I'll leave that up for a second. All right. Now, let's do the first one kind of together. In triangle PQR, we're trying to find side R here. And you guys should notice this is a side angle, side triangle, so we can't use the sine law. It's one of those cases where we need the cosine law. Normally, I don't need you guys to write the formula out, but I think for at least our first one together, it'd be a good exercise in writing out all the letters. So if we have little r squared, what does the cosine law say? Well, that will equal to the other two sides, which would be p and q. So p squared plus q squared. And then it's always minus 2 times those other two sides, p and q. And then always times the cosine of that matching angle. We're finding side r on the left, it's angle capital R there. So I think for the first two, we'll get a bit of practice setting it up. But then it's just kind of calculator work. Side P is 38. So 38 squared. Side Q is 55 squared minus 2 times 38 times 55 times the cosine of 70 degrees. Now, with these, if I was teaching maybe the grade 11 college course, I might do this calculation in steps. But with these academic level courses, we all should be using a scientific calculator, and your scientific calculator, it can handle just putting that all in at once. So I think that's what we'll do. We'll just check with each other before we kind of go on and finish it off. I usually keep a decimal place or two. I'll go to one maybe. 3,039, if you round to one decimal place, 0.4. Do you guys get that too? Well, obviously that's way too big for this triangle, right? But remember, just like Pythagorean theorem, we haven't found the side length here. We have found the square of the side length. So you just have to square root that. Now I'll show this extra step. In practice, you can just go right to r. But yeah, now we just square root it. And it's about 55.1. And in this case, millimeters. It's a bit of a mouthful, the cosine law, but on the other hand, there's no rearranging. It's just calculator work. That's kind of nice too. Can you guys try the next one, and then maybe we'll take a question if you have them. So we're finding side B in this triangle. Don't peek on the front side. Can you guys set up the cosine law with the appropriate letters? Don't have a peek, just give it a try. And then when you're doing practice, you can plug stuff in. And I think maybe for this one too, I'll talk about what I would expect to see for like a minimum amount of work. All right, here I come. So it's always the other two letters squared, a squared and c squared here. Always subtract 2, and then a and then c times the cosine, this time of angle B. Now, if you're slamming out a lot of these, or you're really comfortable, you can just actually get the side length in one step by just doing what we did before and square rooting. You can do this all in one step if you'd like to. Do 35 squared plus 55 squared minus 2 times 35 times 55 times the cosine of 50 degrees. Your calculators can handle this. And you can get right to your answer. But just to be clear, like this is what I would consider the bare minimum for work to show. Are you in degree mode or are you in radians mode? Okay, I'll come check. So see what you get, check with your C partner. I'll come along for the ride in a second. And if you guys can go on to that last problem, we're going to solve that triangle. You do need to use the cosine law first. I'll let you guys give that a try. And we'll sort it. Do you remember the cosine of cosine? And then you can just, then one step here, you can just root the answer. And then Okay. Put it into 2. All right, my first one ended prematurely, so this is part 2. But let me play catch up here. So 35 squared plus 55 squared minus 2 times 35 times 55 times cos 50, and then square root that. I got 42.1. Okay, see some nods. And in this question, we're working with meters. So I've taught the cosine law like probably 25 or 30 times now. I feel like doing 2 or 3 more of these, it's going to become a bit overkill. Eventually, you just have to just practice it, and it's the same every time. So we'll do that here with a bit of a twist. So we're solving this triangle, which means we're finding all the unknown sides and angles. And I'll just talk strategy with you guys first. This is a side angle side triangle. You do not have a choice except to find side E first using the cosine law. Then I'd like you guys to find an angle using the sine law. We'll mix that in, and then we'll find the third angle by subtracting from 180. So cosine law, and then we'll use the sine law. Let's all find D first, and then we should all have the same answer, sine law. And then we'll find angle F using 180 degrees. But I'll let you guys get going on that, and then I'll pass around the assignment I have for you guys. And then lots of 40 minutes of just time to work. That's my kind of day. I love giving you guys assignments that are worth stuff. Keeps you motivated. It's more work for me to mark, but. I thought you got like 24 on the last one. Oh, I threw it twice. So feel free to move around rows if you want to make a group of 3 somewhere to work on that. Is that okay? Yeah. And then once you guys get going, I'm free to help you with this or anything from the past days. You can just let me know. All right, I'm going to come along for the ride here. So firstly, we're going to find E, and I'm going to do we've done a couple showing a lot of work. I'm just going to do kind of the direct way to calculate E. So we do the other 2 sides, 4.9 squared plus 6.2 squared minus 2 times 4.9 times 6.2 times the cosine of 64. You can do that all at once. Plus 6.2 squared minus 1.6 6.3 times cosine of 64 equals, don't forget the square root. Really tempted just to call that 6. Do you guys get almost 6? 5.98? No? Did I put in my numbers right? More blank stares than usual, and I've already messed up a couple times today, so let's double check that. Cosine 64 root. I got the same thing again. 6? About 6? Oh, okay. Why did you guys look at me like I was talking nonsense? Oh, okay, I'll come double check. It's probably just entering. It's like 5.98. I'll keep that. We'll figure it out. And then I'm going to find side D next. or angle D, excuse me, sine D over 4.9 equals the sine of, I now have my side angle pair of the E's. Okay, and then I'll let you guys finish that off, and then you can find the remaining angle. Let's figure this out. So, okay. Oh, I know. So if you put the root there, you gotta do eventually root and then put a bracket first. Yeah, so here's what I do. So I'll do 6.2 squared. What's the other one? 4.9. Yeah. Yeah, this is an easy fix because you're doing everything perfectly. 9 and the angle is 4. Yeah, so we get that, and then you just do square root the answer. Okay, after that, did you see what I did there? All right, so sine D. And as I'm doing this, so for the 3U people, again, yesterday's stuff might be fresh in your minds. Clearly, this is an acute triangle, so our calculator will give us the correct angle here. I need you to do at least the bare minimum, like I did in part 1 here. I need to know what you're plugging in. Yeah. All right, I'll be naughty here and work left to right. 7, 3, 6, 5. I got 47.4 degrees. And then we just got to find angle F. 68.6. Okay, I'll be right there. 68.6. All right, so it's the cosine law, finding sides. You guys just need to, yeah, Kennedy? Okay, yeah, just I think for both classes, the first 3 pages are all the same. So work with your 3M friend, work with your 3U friend, it's all the same. For the 3U people, I added a few questions based on the last couple of days of content that was specific for you guys, just to try to keep that stuff fresh and give you a chance to practice it, okay? So I'm going to pause the recording. 3U people at home that missed class today, the assignment's posted there for you guys as well, so you can work on it this weekend.